Hi everyone. In this session, we'll see some advanced topics of behavioral modeling. Like we'll see what are the conditional statements that are available in behavioral modeling, and how to do the looping statements in behavioral modeling, and how to do the multi-way branching, and we'll see some examples also. So these are the contents of this session. First, I will explain what are the different conditional statements that are available in Verilog. Then we will move to multi-way branching, in which we can do the nested conditional statement using a simple case statement. And then we will move to what are the different types of loops that are available in Verilog. Like there are basically 4 different types of looping statements that are available. We will see each of them with some examples. Then we will move to what is sequential and parallel blocks and how to use them. Finally, we will see some examples to understand these topics. So let's move to conditional statements. So what are conditional statements? What are they used for? They are used to make decisions based upon certain conditions, right? In real world, we'll always require the condition. If something happens, then we need to do something, right? Some set of statements. This is control and this is execution. If something happens, based on the control signal, we'll execute some set of statements. Else, if this thing not happen, then execute this set of statements. It is very much similar to the C language, right? In C language also we know how to use if and else. Similarly, we have if and else here in Verilog also. Basically, there are 3 different types you can do the conditional statement. The first type is only if, and second one is if and else, and third one is nested if else if. This is nested if else if. And in Verilog, how to define true or false? True means if the condition is either you can directly write true, or the condition is resulting into the condition or expression is resulting into logic 1 or any non-zero value. Like if the expression is resulting into a value of 7 or 15 or 25, any non-zero value will be taken as a true. Similarly, the false will be taken as either you can directly write false, or you can have an expression which is resulting into either 0 or ambiguous value x. In this condition, the condition will be considered as a false and the if statement won't execute, else statement will be executed. Let's see an example of ALU controller so that you'll get a clear cut idea of how to use the conditional statements. Let's say you don't have multiple alternatives, and if you have only one statement, then you can use simple if. There is no need of writing else also. So in that case, you can write simple if like this. Let's say my ALU controller is my control signal where I used to check the condition. So if my ALU controller is 1, then what happens? That means it is true. So this set of statements will execute. Let's say if my ALU control is equals to 1, then if I write x is equals to a plus b. So if my ALU control is equal to 1, then x is equal to a plus b will be executed. If my ALU control will be 0, then it won't go inside this loop, it will follow its original order, right? So this is only if statement. If I want to use if and else, then I can write else. So what happens if my ALU control is equals to 1, then a plus b will be executed, else my x is equals to a minus b. A minus b will be executed. So here I am doing addition, here I am doing subtraction. So with single bit, I can perform any one of these statements. If it is true, then it will perform addition operation. If it is false or 0, then it will perform subtraction operation. Let's say I want to perform multiple operations, then my ALU controller should be now at least 2-bit data. If it is 2-bit binary data, then it can have at least 4 different operations, right? 0, 0, 0, 1, 1, 0, 1, 1. Similarly, you can write 4 different operations using if, else, if, like this. Let's say your ALU controller is 2-bit data. In that case, we'll start with if ALU controller is equals to 0, what happens? So this is decimal 0, this is decimal 1, this is decimal 2, decimal 3. So I am directly writing if my ALU control is equals to 0. So see, this is logical equals to, not simple equals to. If you put simple equals to, then it won't take it as a equal to condition, checking of equal to. It will just assign ALU control to 0, which is a syntactical error, right? So because that is not a condition, that will give a syntactical error. You should always give a condition here, not a assignment. If you put only single equal to, it will take it as an assignment, but assignment won't be a condition, so it will give a syntactical error. So be careful, you have to give double equals to check the logical equality, right? So if my ALU controller is equals to 0, then I want to perform my x is equals to a plus b. Okay, I am performing addition. Else, if, till now I am writing if and else, right? You can write else if. Else if means some other condition. Else if my ALU control double equals to 1. So if my ALU control equals to 1, I want to perform x is equals to a minus b. Okay. Again, I can write else if my ALU controller is equals to 2. In that case, I want to perform my x is equals to a multiplied by b. Okay. Since I have written all the three combinations, there is one more combination which is left. Either I can write else if my ALU controller is equals to 3, or I can simply define this as a default case. If all of these three are not executed, then it should go to my default case. In default case, you can directly write without any condition, because that is the default condition. If any one of these is not if all of these are not executed, then it will directly go to default case. In default case, let's say I want to perform a mod b. So this is modulus operator. So by this way, I can perform 4 different operations using 2-bit of ALU controller. By checking the condition of the ALU controller, if the ALU controller is decimal 0, then addition will be performed. If it is decimal 1, subtraction will be performed. If it is decimal 2, then multiplication will be performed. If it is decimal 3, then modulus will be performed. So this is if statement. The same thing you can perform using multi-way branching, because it looks like branching, right? Whether you want to perform this or this or this or this. So the same thing can be done by using a multi-way branching statement called case. So it is an alternative of nested if else if. The case is the keyword we need to use for multi-way branching. And there are special cases like case X and case Z. I will explain them in the further slides. So what are the rules of case statement is the expression is compared in the order they are written. In the if else if statement also, it will be flowing like this. First it will check whether if statement is true or false. If it is not true, then it will go to else if statement. Then if it is also not true, then it will go here. Then if it is true, then it will execute and it will come out of the loop. If it is not true, then it will go to default statement. So it will follow the order that we have written. In the same way, the multi-way branching statements also will be followed the order that we have written. And you need to remember, you should not place multiple default conditions in multi-way branching, as well as in the case of if else if condition also, you should not put multiple default conditions. So let's take the same example of ALU controller, in which my ALU control is a 2-bit data, right? It is a 2-bit data. It can go from 0, 1, 2, 3. So in this case, how to use the case statement? First of all, we will see the syntax of case statement. Syntax of case statement is like this. You need to write keyword case, and then here you need to write the expression. After you have written the expression, you need to start writing the different alternatives. So alternative 1. If alternative 1 is true, then what kind of statements I need to execute? Statements for 1 and semicolon. Similarly, alternative 2 and its corresponding statements. This can be either a single line statement or multiple lines of statement. If it is multiple lines of statement, you know how to write the multiple lines of statement. You have to use begin and end. Inside the begin and end, you can write the multiple lines of statements. Okay. Again, alternative 3 and its corresponding statements, so on up to you will find the default. In the default, you don't have any expression. You can directly write default and its corresponding statements and end case. Whenever you are ending, you should end the case. Okay. This is beginning of case and this is the end of the case. So let's see the ALU example. So how to do the ALU control that we have performed in nested if, the same thing I can perform using case statement like this. Case, what is the expression I need to give? My expression is ALU control, right? ALU control. Now my alternative one is 2-bit binary 00, right? In this case, what happens? My x is equals to a plus b. So this is the statement. This is the alternative 2-bit 00. In this alternative, if my ALU controller is 00, then this statement will be executed. Similarly, if my ALU controller is 2-bit 01, then my x is equals to a minus b. If it is 2-bit binary 10, then my x is equals to a multiplied by b. You can either write 2-bit binary 11 or you can directly write default. Default x is equals to a mod b, right? And then you can write end case. So let's say I want to use case statement for 4:1 multiplexer. Okay, how to do that? You can simply write 4:1 multiplexer using case statement like this. So what are the inputs of the multiplexer? It has two control signals. Let's say 4:1 multiplexer. It has 4 inputs and 1 output. One of them will be connected based on the control signals S0 and S1. So in this case, the control signals are S0, S1. So you start writing case. You can use concatenate operator like this, S0, S1. So if S0 and S1 are 00, then what happens? You can directly write 2-bit binary 00. If both are 00, then what is the output? My output is equals to I0. Output should be connected to I0. This is I0, I1, I2, I3, let's say. Then output is equals to I0. Similarly, if it is 2-bit binary 01, then output is equals to I1. If it is 2-bit binary 10, output is equals to I2. If it is 2-bit binary 11, then output is equals to I3. So here I have written all the 4 possible cases. In the default statement, I can write different statement like this. You can display invalid output, any message you want to display, because if it is not falling into one of these things, maybe S0 will be X and S1 will be Z. So X and Z are not falling into one of these 4 alternatives, right? So it will go to default statement and it will say invalid selection. You can write invalid selection. So it will display this message that the S1 and S0 are invalid selection. Either one of them is 1 and other one is X. That condition is also not given in the alternative. So in that case, it will go to default condition. So it is always better to give all the possible combinations that will result into different alternatives, right? So we'll see with one more example, demultiplexer 1:4, where we'll try to address all the possible combinations of the input. Okay, the case statement with X and Z inputs. Till now we haven't used any X and Z as the inputs. See, we have only used either 0, 1, and all the remaining conditions we are using as a default condition. But it is a good practice to define all the possible combinations of inputs so that your output will be a known value. Otherwise, in this case, what happens? Your output is a unknown value, because once if the S0 and S1 are 1 and X, there is no statement that is defining my output. So my output will go into an unknown value. So to avoid those kind of conditions, it is always good to describe all the possible input combinations. So how to do that? Let's take an example. Let's take an example of demultiplexer. So what is a demultiplexer? It has one input and it needs to pass to one of the four outputs. So it has only one input in and it has four outputs: out 0, out 1, out 2 and out 3. And again it has two control signals. Based on the control signals, it will decide which path should be activated, whether out 0 path is activated or out 1 or out 2 or out 3 based on the control signals. So let's write the case statement. So case, here same, my control inputs I am giving S0 and S1. So I am using the concatenation operator and then I am checking, not required, case of these two, right? So what are the different combinations that are available for S0 and S1? 0 0, 0 1, 1 0, 1 1. Or what are the different values that a signal can assume? It can assume 0, 1, X and Z. So S0 can have 4 values. Similarly, S1 can have 4 values. So what are the possible combinations that it can have? 4 into 4, total 16 possible combinations that it can have like this. This is 1, 2, 3, 4 and this can be 0x or 0z, right? Similarly, this can be x0 or z0, 1x, 1z, x1, z1 and x, x, z, z. How many combinations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are two more combinations like zx and xz. See, there are total 16 combinations. We need to address all the 16 combinations, otherwise your output can be an unknown value. So if you can define all the 16 possible combinations, then your output is a known value. That we'll see how to do that. So I'm defining case statement for this expression S0 and S1 and I'm start writing the different alternatives. First we will start with this alternative. If my alternative is 2-bit 0 0, 2-bit binary 0 0, then my, since there are multiple lines of outputs, I need to use begin and end. I can write like this: begin, my out 0 is equals to, in this case out 0 is equals to in, and my out 1 is equals to 1 tick binary Z. It should be in, all the other outputs should be in high impedance state. Out 1, out 2, out 3 all are in high impedance state. Similarly, if my alternative I have used begin, I need to end. So this is set of statements for 0 0 alternative. Similarly, for 0 1 alternative, I will again begin and my out 0 is equals to now 1 tick binary high impedance and my out 1 is equals to in and my out 2 is equals to 1 tick binary Z and out 3 is also equals to high impedance and end. Similarly, you can write for 1 0, in that case my out 2 will be in and remaining all are 1 tick binary Zs. Similarly, 1 1 case, my out 3 will be in and remaining all are high impedance state. I'm not writing them, you can understand, right? So far we have defined only 4 possible combinations. So what happens if these combinations are appearing? Let's say S0 is 0, but S1 is X. In that case, what should be my outputs configuration? So how to define them? So I'm erasing some of the case statements. These alternatives I'm erasing. So in that case, you can write multiple combinations in single alternative. So far we are writing only one alternative, right? We are writing one alternative and then its corresponding statements. But you can write multiple alternatives by using a separator called comma, like this. You can write 2 tick binary x0 comma, this is one alternative, and 2 tick binary x1. See, this is one and this is one. I am writing multiple alternatives in single line, comma 2 tick binary xz, comma 2 tick binary xx, comma 2 tick binary 0x, 2 tick binary 1x, 2 tick binary zx. In all these combinations, see all these combinations, I am defining one at a single line. In all these combinations, my outputs should look like this. Begin, my out 0 should be x, out 1 also should be 1 tick binary x. Similarly, out 2 is also x, and out 3 is also x, and n. So, if any of these combinations appear, then my outputs will be x's. Similarly, what are the different combinations that are left? 1, 2, ZZ, Z0, this combination we haven't defined, and Z1 we haven't defined. Similarly, 0Z also we haven't defined, and 1Z also we haven't defined. So, for these combinations, I will write like this. I will write here for the remaining combinations. Same, you can use comma separator, 2 tick binary Z0, comma 2 tick binary Z1, comma 2 tick binary ZZ, comma 2 tick binary. This is also not defined. So 2 tick binary Z0, Z0 is already defined, 0Z, comma 2 tick binary 1Z in all these possible combinations. So it should be ended with colon. Now you will write the statements. Here begin all the outputs. Out 1 is equals to 1 tick binary high impedance. Out 2 is equals to high impedance. Similarly, out 3 is equals to high impedance. Out 4 is also equal, no, 0, 1, 2, 3, right? We are defining. Out 3 is also equals to high impedance, and n. So now see all the 16 possible combinations we have addressed. Now you can write, if you want, you can write a default, or you can leave the default statement also. Default, you can display whatever message you want, right? Since all the possible combinations are addressed, it will never go into the default statement because we have addressed all the possible combinations that it can have. So in the default, you can write whether unspecified control signal, like that, whatever message you want to display. But it will never go into this default condition because we have already defined all the 16 possible combinations that can happen with S0 and S1, right? So this is the better way of coding. You should always define all the possible combination of inputs and its corresponding outputs so that you will be aware that what will be my output. Otherwise, your output will be unknown state if some other state has appeared which is not defined in the case alternatives. Okay. Now, yeah, now let's see what is case X and case Z. These are two different keywords that are used to compare non-X and non-Z positions. Okay. Let's take an example of encoder or priority encoder. You must have known what is a priority encoder. It looks like this. If my input combination, let's say it is a 4-bit encoder. Okay. If my input combination is like this, 4-bit 1xxx, in that case, it should encode to output or next stage should be equals to, this is a third position, right? This is bit 0, bit 1, bit 2, bit 3. So the third bit should be high. So next state should be 3. Similarly, if my 4-bit binary combination of x1, xx. So what does this mean is, no matter what will be the value of these positions, if my second bit is 1, then my next state or output should be equals to 2. That is what priority encoder. It is always giving the priority to this particular bit, to the bit which is 1. You can say 4-bit binary xx1x. So here the priority is given to bit 1. So my next state will be 1. Similarly, 4-bit binary xx x1, since the 0th bit is 1, no matter what is the value of this, it should always go to next state as 0. So how to write that using case X statement? You can write like this. So I am taking this 4-bit binary as a encode input, that is my input, encode underscore input, which is a 4-bit value that I will get. Okay. I need to compare this 4-bit value. So I am writing case x. I'm not using case statement, I'm using case x statement. Case x encode in. So this is a 4-bit input that is coming from outside. In that case, what are the alternatives? 4-bit 1xxx. That case, my next output is equals to, next state is equals to 3. Similarly, if it is 4-bit x 1xx, then my next state is equals to 2. 4-bit xx 1x, then next state is equals to 1. 4-bit xx x1, then my next state is equals to 0. Okay, now that we have defined 4 different combinations, you can write the default statement. Default, you can write next state is equals to 0. By default, it is a next state of 0. You can write expression also in the default statement, not just display statements. You can write the expressions also. Expression means statements also. So what let's see what happens. So we have started a case, so we need to end the case as well. You should not end with case x, you should end with end case only. Okay. So let's say my input is 1x0z. So in which alternative it should go? It should go to this alternative, because the priority encoder will see where the 1 lies. In this case, it is lying at this, and this x0z will be compared to xxx, because we have used case x. Otherwise, it won't match. If you use simple case, then this will be taken as a default condition. But here we have used case x, these 3 will be matched with xs, and it will implement this set of statements, right? And we have seen that it will flow in this order, whatever the order you have defined, right? So what does that mean? So if the value of 4-bit encode input is 0 1 1 x, in that case, which alternative it will go? It will go to, first it will go this alternative, because this one will be uncounted first compared to this one. So it will go into this alternative. That's why the order is also important. The way the order is defined will be the execution order. Okay, I hope this is clear. This is the multi-way branching that is available in Verilog. Now let's see what are the different looping statements that are available, right? Similar to the C language, we have while loop and for loop, but there are 2 extra loops that are available in Verilog. They are called repeat and forever. We will see each one of them with examples. So one important thing you need to remember here is all the looping statements can appear only inside initial and always blocks, because it is a behavioral code. Whatever the behavioral models, what are the behavioral statements you want to write, they should be appear inside initial and always blocks. So where do we require looping statements? Same as in C language, we will require looping statements to execute same set of statements for multiple times. Whether it can be based on the condition or without condition. If you want to execute some set of lines or some set of statements multiple times, then you will go to looping statements, because it will reduce your complexity of the circuit. Otherwise, what you need to do, you have to write that multiple statements multiple times in the code. Instead of doing that, you will define them as a subroutine and put it inside some block, and then you will call that block multiple times. That is the purpose of looping statements, which is very helpful for designing complex circuits. So let's start with while loop. While loop executes until the while expression is not true. So this is the condition for while loop. So it has 3 different things. First we need to initialize, then we'll check for the condition, then you need to increment also the condition. Otherwise, if you don't increment, then it will stay in that condition, it will repeat for forever. So let's take an example of counting up to 128 numbers. So how to do that using while loop? First of all, as I already told, it should be inside the initial or always block. Here I am using initial, and begin my count is equals to 0. I am defining an integer of count. Okay. What is my task? I want to display from 0 to 127. So my count is equals to 0. I am initializing. Then I am writing the condition while. The keyword is while. Here I am writing the condition until count less than 128. So it will count up to 127. If the count is equal to 128, this statement will be false and it will exit the loop. Until 128, this statement will be true and it will execute the what are the statements we have inside the while. Here the statements I am writing: begin, display, count is equals to percentage d of my count. So what it will display? It will display count is equals to 0, count is equals to 1, count is equals to 2, like that. It will display until count is equals to 128. So begin, I am displaying again. I need to write my increment statement also. Count is equals to count plus 1. If you don't write this, what happens? Always the count is equals to 0 and always the count is less than 128. So always the while loop will be executed. Once you give the increment, then only it will check for next condition, whether count is initially count is equals to 0. Then it will go inside this loop. It will execute this statement, display statement. Then it will increment the count to 1. Again it will check whether 1 is less than 128 or not. Again it will check 2 is less than or 3 is less than until the count reaches 128. Once the count reaches 128, then this while loop will be exited. So and it will exit from the while loop and it will continue with its own flow. Right? This is how you can write the while loop in Verilog. Here I have given only one condition. You can give multiple conditions also. Multiple conditions can be given using different operators. We know different operators like AND operator, OR operator. You can use any operator and you can give multiple conditions like this. While you can give I am giving two different conditions here. While my I is less than 15 and this is logical and my control is equals to 1 or 0. So what happens here? It will check for two conditions. This is condition 1 C1, this is condition C2. If both C1 and C2 are true, then only it will execute the following set of while statements. If any one of them is false, if my control is 0, then it is a false. If this is false, then end of false will be 0. So while of 0, because it is a false, it won't execute the set of statements. By this, you can give multiple conditions also. In this particular case, since I have used AND, both these conditions C1 and C2 should be true, then only it will execute the set of statements. If you want any one of them to be true, you can use OR operator. Instead of AND operator, you can use an OR operator. What happens here? If any one of the condition is true, if control is equals to 1, no matter what is the value of I, it will execute the set of statements that are defined inside the while loop. By this way, you can give multiple conditions also in the while loop. So this is all about while loop. Now let's see what is a for loop. A for loop is a compact version of while loop, you can say, because it will also do the same task whatever while is doing, but it is a compact version. It has three parts: initialization part, condition checking part, and procedure assignment change part, which will change or increment the condition. Same thing we have seen already in the while loop also, right? So same example we'll take. We want to count up to 128. So how to write using for loop? We can use the keyword of for. This is small letters. For, you can start initializing. There I have used count is equals to 0 separate statement. Here I can directly write count is equals to 0. Okay. This should be an initial block, right? Because as I already told, all the looping statements should be inside either initial or always block. Initial for count is equals to 0 and my count less than 128. So this is the initialization condition. This is the condition checking. And now the procedural assignment to change the value of the control variable, which is count is equals to count plus 1. Right? You need to use semicolons between these to separate them. Okay. See what happens here. First, it will check whether count is equal. It will assign count is equals to 0, and then it will check if the count is less than 128. Then it will go inside the begin statement and it will display whatever display, or it will perform whatever the statements you have written there. Here I am only displaying same thing. I am displaying my count is equals to percentage d comma count. So it will start displaying count is equals to 0, count is equals to 1, count is equals to 2, up to count is equals to 128. Once count is equals to 128, it will exit from the for loop and it will do the remaining statements whatever there in the code. Okay, this is for loop, which is a compact version of while loop. So now let's see an example how to give multiple for loops in a single initial statement. You can give multiple for loops as well, not just a single for loop. You can give any number of for loops in a single initial or always block like this. I am taking an example to give two different for loops in a single initial block. So I am initializing and then begin because multiple lines are there inside begin. So what is the task I want to do? I have a variable called state. Okay, in this it is a 32-bit data. In this state I want to assign alternative zeros and ones. All the odd positions with 0, all the even positions, these are odd and these are even. All the odd positions with 0, all the even positions with 1. So for that, how can I do that? Using two for loops. For I will start I is equals to 0, I less than 32 since it's the 32-bit. Then I is equals to I plus 2. Instead of I plus 1, I am doing I plus 2 so that I will skip the either even or odd ones. If it is starting with 0, then next will be I plus 2 means it will go to second bit. This is 0th bit, first bit, second bit, third bit like this, right? First it will start with 0th bit, then it will go to second bit, then it will go to fourth bit, sixth bit, eighth bit like this. All the even positions it will do. In that condition, what I want my state of I. See, I am assigning using for loop variable I. State of I is equals to 0 because I want all the odd positions should be 0, right? Similarly, the other statement is for here I need to start with I is equals to 1. Okay, for I is equals to 1, again I less than 32, my I is equals to I plus 2. Since it also started with 1, it will go from 1 to 3, 3 to 5, 5 to 7, 7 to 9 like this. At that state, I want my state of I is equals to 1 and n. That's it. With this, you can write alternative zeros and ones into your state vector. This is a vector of 32-bit. By this, you can write multiple for loops inside a single initial block.